Hello, everybody, and welcome to Sensophilia Sparring Partners. This is Monica Paolini from Sensophilia, and I'm your podcast host today. And today I have Preston Marshall as my guest. He is the Director of Wireless Standards Policy at Google, and he's also the co-chair of the Spectrum Sharing Committee at the WIN Forum, and the chairman of the OnGo Alliance, which is CBRS. So what we're going to talk about today, and this is going to be a little bit different than other episodes, we're going to talk about Press' last book, which is evolving to 6G. And this is interesting, and I'm going to have a link to it on the notes. It's interesting because I found it to be a very refreshing book, because while it talks about 6G, it also gives us a lot of it's a reflection of what happened up to 6G, so history and present of wireless and telecoms. And it's just a good place to kind of think about a lot of issues that we often do not look at the high level. We got into a lot of details, and sometimes we miss the big picture. So today's going to be a big picture and yet very concrete discussion. So what I would like to do is, first of all, to ask Preston to introduce himself, and then we can go and give a little bit of a description about the book. So, Press, who are you?
Okay, I'm Press Marshall. I am, as you said, currently at Google. This book is completely my private project. Been working a lot with the 3GPP ecosystem, the Wi-Fi ecosystem, and private networks and CBRS. I think they've given different perspectives. I think a lot of people who have been in the classic MNO focus on the various Gs. And I thought there were some things that were being kind of missed as people were rushing in to solve specific problems in 6G. I'm a system engineer by heart, and I thought we should come back and say, what's the reason why people are concerned? The fact that there are stories, why has 5G failed? But whether you think it did or not, the stories are out there. And so obviously there's concerns. In the past, I think we've always thought, geez, the next G is like the next fighter airplane in the 50s. Goes faster, quicker latency, some fairly simple metrics to move the network along. And certainly going from 2, 3, 4 to 5G, you can measure them with a speed dial. There were simple scalars. And so in this book, I wanted to look at some of the other attributes. Maybe we reached a point where just speed is not the critical issue. Maybe it's not in the RAN. Maybe it's in the fact that in 5G, we really reimagine the control plane. So focusing on the control plane, what could we do with that control plane? Don't necessarily cause us to have to use new technologies throughout the whole network. In particular, you have to recognize that 3GPP technologies are 10, 15% of wireless. The bulk of wireless is Wi-Fi. And so if we're going to talk about becoming a unifying technology, we have to unify with Wi-Fi. We can't just continue to ignore it. Trust is an attribute that's not measurable in speed, and yet the literature is full of various two-factor authentication frauds. The telephone number is no longer a telephone number used for billing by operators. It's become people's identity in much of the world. And we need to rethink the trust boundaries that allow people to trust a telephone number. Some other concerns were that we built 5G around what operators thought they needed. We're building 6G in the same way. And yet the bill payers for that aren't consumers. They have to be different enterprises, hyperscalers, private networks, and they're not really at the table. So how do we bring them to the table? And no one can write about anything these days without talking about AI. And so again, we see lots of approaches. We should use AI for this and that. perhaps prematurely optimizing it rather than saying we don't know what AI can do to it and how do we expose the information in the network to AI without prematurely locking in very specific techniques. So there were a large number of issues. They more focused on the control plane than on the RAN. I'm a radio guy. I hate to admit it, but we're kind of pushing Shannon limits. Our antennas are consuming more power than our transmitters, and so we're reaching a certain point of relatively diminishing returns. So as we think about the next G, what would happen if we focused on the core rather than on the edge? How's
Yes.
that for 170 pages? One shot.
Yeah, no, and I would encourage everybody to read it because it's like it'll give you a lot of things to think about. And as you said, the focus on the core and the fact that it's not just the RAN performance is somewhat unusual. But I think it's due because we made a huge amount of progress, and there is a sense in which, come on, it's like in terms of technology, isn't that wonderful what we achieved to date? And people might just have different opinions about 5G. When I was 13-year-old, I didn't even have a fixed phone, let alone a mobile phone. And now to think of living without a phone, and with a phone I can do it, it might not be perfect, but there's so many things I can do. So we often are so critical about it, but it's actually a wonderful technology. And yet there is a sense in your book, and I completely agree with you, that the technology, we have more technology. Well, the technology is there, but we could use the technology in a better way to serve the purposes of it, which is to provide connectivity services and all that. And so just making it faster doesn't address those issues because they're sort of like a different type of issues. It's not an issue of RAN performance, where we're doing actually pretty well.
Yes.
I mean, if we can do better, I mean, why not?
Yeah.
I mean, nobody's going to complain about it, but that's not a major challenge.
I think it's clear they're not going to pay more for it. We've certainly run that experiment. Yes, and the things that I mean, I have all of us have two wireless experiences. We have a Wi-Fi experience. We have an outdoor cellular experience. We can maintain that for the next, if it's 10 years per decade, we can go several more generations. We maintain that partition. The fact is that for most people, the cellular experience is a better one. Wi-Fi has all kinds of authentication problems. It is not centralized. It doesn't have a control plane. It can't make commitments. It's a best efforts. So in many ways, Wi-Fi is a poor experience, but all that's free spectrum. And the fact that it has new technology generations every 2 years cures a lot of ills. And so we have really an incredibly adaptive, particularly for indoors, RAN technology. We have in 5G for the first time a cloud-based, flexible, adaptable control plane that solves many of the problems Wi-Fi has. And Wi-Fi provides the bandwidth where people are most of the time, which is indoors. So then one of I think the core principles in the book is it's really time to rethink, do I really want to have two wireless silos? Is that good business model for operators where they essentially have walked away from indoor coverage, where we all are? I mean, you've walked away where customers are 85% of the time. And they've almost ceded that to cable companies. So I don't think it's necessarily a good thing for their business model. Very clearly, as we move ahead in spectrum, we're moving up and up and up. And I see people talking about 40 gigahertz and all that. And then for the cells, in order to find it there, well, we've learned what happened with millimeter wave. It doesn't go indoors. If you want to understand, if you need a street map of DC, you can bring up Verizon's millimeter wave coverage because it's up and down the streets, but it doesn't go in any of the buildings. And so we're not going to be able to build 5G experiences indoors by pounding energy in. We're not going to get people to spend the money on DAS inside buildings. So if we really believe the 5G experience is critical to consumers, then we have to think about how do we bring the outdoors and the indoor technologies together. And it's not hard. It's just a decision we have to make.
Yeah. So let me just say that there is something I actually disagree with you. That you said that the cellular experience is better than Wi-Fi. No, to me, it's like it's actually,
not by bandwidth, but in terms of the fact that you can roam around the world, that it can carry charging and connections across the network, that every public network is identifiable with a framework. All of those make for a better experience, not in terms of bandwidth, but in terms of the user experience.
Yeah, but if my user experience is to be able to do whatever I want to do, right? And with Wi-Fi, if I'm in a place where there is Wi-Fi, which is not everywhere, obviously, usually my experience is better.
Because of the bandwidth.
Because of the bandwidth.
So one has better bandwidth, one has a more, let me say, more seamless experience.
And coverage indoors.
Yeah, seamless.
Yeah. So the authentication part is a little bit more tricky, but it's actually not as bad. I mean, it used to be terrible, but now,
really not as bad.
If you keep going to the same places, we're kind of like,
yeah, you get into a rut, and then you go to a place and you walk into a building the first time and you go look for the guest network, and maybe you have to sign on, maybe you don't.
But usually it doesn't take a whole, I mean, it used to be more, it's not ideal. But once you understand that that's the way you do it, well, you kind of survive.
Okay, so the best thing you can say is you've learned how to adapt to it, what it doesn't do.
Okay, but I can say the same thing about cellular, right?
Yeah, we shouldn't be adapting users to the technology. We should be adapting the technology to the users.
I agree with you, but what I'm saying is that both technology requires me to adapt. So I need to know that if I'm indoors, forget about cellular. And then if I'm outdoors, forget about Wi-Fi. And then if I go to a new place, well, whatever. So anyway, but let's go back to the fact that, okay, we know that people are not willing to pay more. But there is still like this kind of like lingering thing that, with 5G, we didn't get more revenues, but with 6G is going to be all different. There is still that kind of mentality, or with standalone or whatever, the network slicing, whatever. And I just don't think that that's really, there is a potential for revenue, but not in just getting people like, even the two of us as users, I'm not going to pay more. And I cannot see of anything that I could be willing to pay more on a monthly basis.
Household income hasn't come up appreciably to support a greater allocation to communications, which is already quite high in most household incomes. So it's unlikely that there's a significant increase. And in fact, if you look at what the proponents of 5G looked for as bill payers and now in 6G, in the book, I go through the Next Generation Mobile Network Alliance, which kind of put together the original business case for 5G, and then the Next Generation Alliance's list of 6G use cases. And you start looking at them and saying, okay, how many of these really create revenue for mobile operators or would be something on mobile operators? How many of them are indoors? How many of them are outdoors? Robotic surgery. I hope they're not doing that in the street. And I really don't even want to see them push they're doing robot surgery in my brain. I think it was an advertisement one of the chip companies ran 5 years ago. I don't want to see them plug a handset in and do it by tethering. Most of these use cases are good use cases, but it's not clear that they're good use cases for the public networks or necessarily for the 3GPP RANs as they exist today. Are people going to invest $10 billion in tooling in a factory that is dependent on the investment cycle of a third party? It's one thing to have your administrative functions running over cellular. It's quite another to say, I'm going to put my factory tooling over it. Robotics is often pointed to as a major business market. Most of the robots are likely to be indoors. I don't imagine we're going to see them walking down the street. Always we talk about transportation. Well, automated transportation will come. I think it's been like 30 years. We've had a special band for that. It hasn't been used. The autonomous vehicle people wanted for maps, but no autonomous vehicle right now can rely on it until we ban human drivers. So cars can talk to each other. As long as humans are allowed to drive cars, we can't take parts off the autonomous vehicle and put communications on. And if we can't take parts off, then there's really not that much attraction. When I first came to Google, I went over to what's now Waymo, which were all people that I knew from the DARPA Grand Challenges, and said, I'm here, I'm doing comms. Look at these wonderful things I can help you do. And they about threw me out because the last thing they want is competing inputs. So a lot of these use cases that have been hypothesized as bill payers are great wireless use cases, but we really should be a little more insightful to try and understand whether they're really use cases for large public outdoor networks or private indoor networks. And I think
Yeah.
that is one of the key questions here.
So from a
How to
mobile
bring those to
operator,
bear.
from a mobile operator point of view, isn't that a problem? Because you could say, well, if I cannot monetize the um, the service, the 6G service that I'm rolling out, can I spend the money? Is it worth for me to spend the money?
I
Because
think they should be asking that. I think it's important they ask it. It's also important that the supply chain asks those questions. To what extent are 3GPP technologies the right answer if I want to build a factory? So one of the tenets of the book is that if let's imagine I'm putting a pallet loader and I'm running it down a warehouse aisle, the faster I can turn it off, the faster I can run it for safety. So the 5G's assured latency, that slicing feature in 5G that hasn't monetized for commercial customers, certainly makes great sense in that use case. That's really an attribute of the core, not necessarily an attribute of the RAN. And so there's a lot of features in the core that could make private networks much more adaptable, but it's not clear that the RAN is necessarily the right technology to install in large numbers inside that building. As chairman of the CBRS Alliance, I'm really pleased we've had so many companies adopt CBRS for factories, and we have a lot of stuff on our website that are those use cases. But they're still a relatively small compared to the millions of factories in America. Most of them already have Wi-Fi. So how to bring the 3GPP control plane and features that allow me to engineer my comm network as compared to best efforts is, I think, a real contribution to that problem. But it may not come through the path of public networks deploying 3GPP RAN. We should be thinking about the core as a standalone product that has utility across, maybe even on LoRa, across the RANs.
yeah, but so if you look at kind of like step back a bit. So if I'm a mobile operator, I clearly want to go 6G and I want to use 6G or 5G or whatever cellular technology as much as possible because that's my business. But if we just look at it from the user point of view, of the overall ecosystem industry point of view, wouldn't we be better off to say, hold on, Wi-Fi can pretty much deal with anything, even if you go and do like robotics. I mean, if you are in an enterprise environment, you control the real estate, you control the space. You can actually use Wi-Fi to have high reliability. I mean, because interference is not an issue because you just kill it, you just manage it. So, so wouldn't we be better off, sort of, as a society, as an industry, to just say, let's just let Wi-Fi deal with that? So all the the advanced use cases, the metaverse and automation, IoT, just let it have Wi-Fi do it. What's wrong with that picture?
To some extent, I think that is what becomes the default. I think people take a look at the package, not just the technology, but the complexity, the management of a 3GPP private network, and then they look at the fact that they can just buy radios and hang them in their factory ceiling. It looks kind of a no-brainer in many cases. I think that's wrong. I think there is a place for the management of 3GPP. The place is in the authentication. The place is in security. The place is in slicing and the ability to guarantee performance as compared to best efforts. Generally very good, but occasionally not. And so what I think people really want is to have something that looks like the kind of computation that they're used to, which now is what 3GPP has in 5G. It's cloud-based. It essentially mirrors Kubernetes. That controlling a mix of technologies, perhaps 3GPP technology in the parking lot or in the loading area, Wi-Fi ran in the factory, but all integrated into one authentication framework, one security framework, one performance management framework, slicing, network capability exposure. Those features are really valuable. If you can look and ask the network, what can you do for me about this device? Where, given it may be far away and so its performance is less, so I have to manage it differently, particularly things that move. I can manage its handovers. It's got a lot of really meaningful capabilities in there. But today it's a package. And so being able to buy sort of one from column A and one from column B, or mix some mixed RANs, I think is really has to be the future. And we built a tool that lets us do this. We can abstract RANs. We now have software. It's just software. It's the same stuff that Google Search, Facebook, all those guys run on. It's not a box that someone comes and plugs into a rack that you can't change. So in 3GPP, the AMF mobility function points to the RAN. It could point to multiple types of RANs. The authentication framework could extend not just SIM cards, but the technology all of us use all of the time, except for a SIM card, which is certificates. Modern enterprise do security on certificates. It does not do it on pre-stored key cards. Not since the Walker brothers gave away U.S. secrets 30 years ago. Has anyone used a symmetric pre-stored key? So everyone's moved on. So if I want to bring this technology into the enterprise, then the 5G core fits beautifully right into the enterprise. It's consistent with the security model, or could be made consistent with the security models. And I think it provides that thing beyond Wi-Fi, which is it gives the factory, whatever, a coherent view of its radio network. So this shouldn't be 3GPP versus Wi-Fi. It should, because when I think 3GPP versus Wi-Fi, I'm also thinking of mobile public operators and private networks as the only possible choices.
Yes, and so I guess that if I'm hearing you correctly, is that we do, and I completely agree with you, we do need to have Wi-Fi and cellular. And I think that we also want, because it's actually good to have more than one technology in general. And they are so fundamentally different, even though the performance might be similar, but the way they operate is different, that it's worth having them in principle, right? But, and I think that this is the important, is that as you stress the importance of the core, you see the core as being non-RAN specific, RAN agnostic. And so it just, and this is interesting because the early efforts to, to sort of get the coexistence of Wi-Fi and cellular was at the access level. So if you remember, there were a lot of, to try to get the same call, to keep the same call over voice over Wi-Fi to go from cellular to Wi-Fi, which is really hard. And I'm not sure it's the right way to go. You just make a new call if you need to. It's not, to have them coexist at the RAN level, at the access level, it's hard and it's not working well. But to have it coexist at the core level, when it's a question of authentication, access, and select the best network. That's more important, which is, I think, actually a reason why in CBRS there's been so much trouble. Is because a lot of the CBRS networks are seen as an extension of the public network. So you go from public to private. Personally, I think they would be a much easier sell if you sell them as an extension of the Wi-Fi network with a core that allows you to pick and choose what you need, but you can support the same services across both networks. If you don't, I think you fail.
Yeah, I think that clearly, I think this, if we could adopt the non-3GPP interface into foreign RANs, I think it makes CBRS a much more attractive feature because you don't have to make this decision about it being all CBRS or all Wi-Fi. Anytime people says you have to be all of anything, it's suspicious. It should set you off. The engineering solution is never the extremes on the graph. It's somewhere in between. So this, I think, would be good for CBRS. Again, I imagine this factory with some Wi-Fi inside where they've got power, electric backhaul. They've got the parking lot, the loading docks with 3GPP. But they're seamlessly because all that integration in 3GPP is in the core. And so when we tried to make Wi-Fi look a little more 3GPP-ish, we tried to do things to APs and tried to create yet another control plane. One's not enough. And then make somehow have the two control planes talk together. No, 3GPP has really, I think, done a lot to create a good vision of what a control plane could be. I'm very anxious to get one running on a Raspberry, just to show how it can scale down compared to EPCs in the prior generations. So if you think about that as kind of the core thing that creates that wonderful cellular experience, then you start to think, how do I take that experience and branch it out into other RANs, even industrial RANs like LoRa, the low energy RAN. Think about how do I introduce other security models. One of the points in the book, talk a little bit like a security geek for a moment, is when we do SMS two-factor authentication. I don't know, how many times today have you typed in 6 digits back to prove to someone that the phone you're typing it into was the phone that got the message?
A lot of times, but actually I never do it from the phone. I do it from the desktop or laptop.
No,
anyway, but yeah,
go with me on this.
No, right. But it's really annoying at the end of the day.
It really is, and it's pointless because it went to the same device. It's because there's absolutely so little trustability in the network that you can't really trust a phone number. And it's not academic. If you look at like Zell fraud, this is stuff up in front of the U.S. Senate with how poorly these authentication methods work, because they put the entire network in the middle. I have to trust the SIM card management by the operator. If I think about it in an enterprise now, and I was doing cloud, the one thing I do is I don't have to trust the intervening networks. I trust my computer. I trust the cloud computer. I don't have any trust in the network in between. And yet in cellular, which is rapidly really key to so much of our social identity and business identity, I have to trust the infrastructure. This is the same infrastructure where people are mailing away to kiosk operator personnel. I'll give you $200 if you flip SIM cards for me. And people social engineer them and all sorts of attacks. It's not a trustworthy network. It can't be made trustworthy network and be consumer friendly. We shouldn't be dependent on it. So if we move along with moving to modern IT, we move away from the root of trust as a SIM card, or coexist with it for the moment, because it's going to take a long transition, to move to something that is asymmetric encryption like certificates. Then most of these things go away. I don't have to trust the operator anymore. To some extent, that's a security model in Wi-Fi. Wi-Fi gives you no guarantee of anything about who you're talking to, so no one relies on it.
But isn't that actually in a way an advantage? Because since you know that you cannot, Wi-Fi doesn't provide security, you have to build it on top. But then it's like independent of the RAN access technology.
It's
Isn't
now
that an
so.
advantage, actually?
And so what happens? People use the SMS, use the RAN framework, SMS over through one of the messaging apps, but they're still dependent on the addressing out of the 3GPP core. So even when you do it over Wi-Fi, because Wi-Fi does nothing, we end up with your phone's on Wi-Fi, but I used your cellular provider's switching framework to get you that message. So I'm come back to the same trust. Operators should not be in the middle of my trust boundary. If you're talking to your bank, you should trust your computer or your handset. You have to trust the bank. You shouldn't have to trust anyone in between. And these Zelle frauds are, in fact, the talking example of this. They're not exploits. They're features of this architecture. So moving to asymmetric cryptography somewhere in like 2000-ish technology, I think was one of the other core things. And again, that would have been really hard in 4G. But in 5G, it's just the authentication function. It's just a Kubernetes service. And so we can extend it. So we now have we're not stuck having to do things the way they are defined in the standard. We can now push it. We can change it. I mean, think about the fact we're building new RANs every, 10 years? Have you seen any cloud product that stays the same for 10 years? That even thinks about is there 1G Gmail? Is there 2G Gmail? Is there 3G Gmail? No, Gmail continually integrates and continuously deploys new features as it moves along, because that's what people want, and it makes the operators, whether it's Google, Facebook, Amazon, it makes them money because they continually adapt it. There's no 10-year schedule. Radios maybe take 10 years. So we need to decouple these things anyway. We need to be thinking about how the core evolves completely separately from how the RAN evolves, as compared to thinking I build a new version of the RAN and then I backfill the controls I need for it, which is kind of what it is. RAN, maybe the core leads. It's a flip. Instead of the RAN leading, the core leads.
Yeah, absolutely. Hey, Preston, our time is up. So, but it was great talking to you, and hope the audience liked it as well. And so thank you all for listening to Sensitivity Sparring Partners. And if you enjoyed, do subscribe and let other people know about it.